Welcome to section 7.2, review of equations of lines and linear models. Hopefully by the end of this you all will be able to write equations of lines in point slope, slope-intercept, and standard form. You will also be able to write equations of parallel and perpendicular lines, and you'll be able to write linear models to represent application problems. So let's go over the different forms of linear equations. The first one is called point slope form because it requires a point and a slope to get started. So point slope form looks like y minus a y coordinate from a point that you have on the line equals your slope, which is the little m there, at times in parentheses x minus the x coordinate of the point on the line. So I kind of have in blue where it's the point on the line, and in red the slope there. And so those points, the x1 and the y1, those will be numbers that you're plugging in. The slope, that m value, will also be a number. So the kind of black y and the black x, those are the ones that will stay in your equation and be your variables. The next format you all might be familiar with is slope-intercept form. That's y equals mx plus b, where m is the slope and the point 0b is the y-intercept of the line. Next up is standard form, which looks like ax plus by equals c. And so that one has x's and y's on the same side. The a, the b, and the c are all integers, so no fractions in this one. We shouldn't have any common factors. It should be in lowest form. And your a value should always be positive, and that's just so we all get the same equation and we don't have more than one standard form for the same line. Some other quick ones. A vertical line, just a refresher, is always in the format of x equals a number, and a horizontal line is always in the format of y equals a number. So now that we've gone over all of that, let's try some. So my first example says find an equation of a line passing through the points -2, 6 and 1, 4. We're going to write our equation eventually in slope-intercept form and standard form and then graph the line. So this one, we're going to do a lot with it. Because we started out with 2 points. We have the point -2, 6, and the point 1, 4. And if you notice, none of our equations, or none of our formats, needed 2 points. They all needed at least a slope. So that's actually going to be the first thing that we do to get started, is we're going to start with finding our slope so that we can get started with one of the equations. So refresher from last time, our slope, we should be doing the change in y values over change in x values. Okay, so my y values are 6 and 4, so I'm just going to do 6 minus 4. My x values are -2 and 1, so I'm going to do -2 minus 1. And again, we should have, our points should be on top of each other. Those coordinates should belong to the same point. Then we'll simplify. 6 minus 4 is 2. -2 minus 1 is -3. So that means that our slope is -2/3. Now that we have a slope and we have a couple of points, we're not quite ready for slope-intercept form yet, but we can start with point-slope form. Because point-slope form required a point and a slope. So just a quick reminder from the previous slide, point-slope form was y minus the y coordinate equals slope times x minus the x coordinate. It doesn't matter which point you pick. You could either pick -2, 6 or you can pick 1, 4, but you have to be consistent and stick with it. I kind of like positive values, so how about we try 1, 4? So if I'm going to use 1, 4, I'm going to have y minus my y coordinate, which would be 4, equals my slope, which we just calculated is -2/3. Then I'll have x minus the x coordinate, and the x coordinate in that point was 1. So that's point-slope form, and it's just a handy way to get started with an equation. If I want to go from here to slope-intercept form, it's really not too bad. I'm just going to distribute and then add 4 to both sides to solve for y. So from here, I'll distribute first, so -2/3 times x is -2/3 x. -2/3 times -1 would be a +2/3. And then to get y by itself, because I want to get into that slope-intercept form, what I'll do is I'll add 4 to both sides. And then I'm kind of thinking ahead here. If I need to add 4 to this side, and I'm going to need to add it to the fraction, I know I'll need a least common denominator. So let's just go ahead and do that along with it. So if I'm adding 4, 4 is the same thing as 12/3, and now they have the same denominator, so that's going to make it easier for me to add. So on the left side, the -4 and 4 cancel out. We'll just have a y on that side. We'll still have our -2/3 x, and then we can combine like terms over here. 2/3 plus 12/3 would be 14/3. And that is slope-intercept form. Okay. So we have y equals our slope, which is -2/3 times x, plus our y-intercept, which is apparently 14/3, which is 4 2/3 if you were graphing it. Next up is getting it into standard form. So first thing with standard form, if you notice, was that x's and y's were on the same side. So I'm going to go ahead and add 2/3 x to both sides. So then I'll have 2/3 x plus y equals 14/3. So I'll have my x's first, my y is second, then an equal sign, and then the constants on the other side. That's the general format for standard form. But the other thing with standard form is that all of your coefficients should be integers. So I can't have 2/3 and 14/3. So what I'm going to do is multiply by my least common denominator, which would be 3. So I'm going to multiply both sides by the same thing, which is okay to do in equation solving because it keeps things in balance. And take it one term at a time. So if I do 3 times 2/3 x, the 3's will divide out and I'll just have a 2x. Plus, I'll also distribute the 3 to the y, so then I'll have 3y equals, on the other side, with the 14/3 times 3, the 3's will divide out and you'll have 14. And that is what standard form looks like for this line. Alrighty, it did say to graph the line. If I were you guys, I would just take the easy way out when graphing the line and plot the 2 points that they just gave you. So you have the point -2,6, you have the point 1,4, and you can connect the dots and form a line. I am going to use a piece of paper to make my line nice and straight. Okay. And the nice thing is that once it's here, you can double check yourself a little bit. If you remember, our slope-intercept form said that the y-intercept was 14/3. So 14/3 is the same thing as 4 2/3, which is exactly where we're crossing the y-axis, so that's perfect. We also have a slope that was -2/3. So down 2 and over 3, which is exactly what we're seeing on our line. So we can double check everything that we just did from our graph. Alright, example 2. Write the equation of a horizontal line that passes through the point 3,4, and then we're going to write the equation of a vertical line that passes through the point 3,4. Okay? So if you guys remember, the horizontal lines is always in the form of y equals a number. So if it's going through the point 3,4, the y-coordinate was 4. So my horizontal line will just be y equals 4, so that it goes through the point 3,4. For the vertical line, vertical lines are always in that format of x equals a number, and so for my point 3,4, the x-coordinate was 3, so I'm just going to say that x is always going to be 3, because apparently the x is going to be 3 for this coordinate. And that's it. These ones are really fast if you know what you're doing, which is kind of pleasant. Okay, now it's your all's turn. You get to try one and show me how much you've learned.